Hello, ladies and gentlemen. Welcome to my today's presentation about bearing supplier development, what is important and how to do it. Let me quickly share my screen with you, and then we can go through some slides which I arranged for this particular topic. So I hope you can see it now. The agenda of my presentation is as follows. First, I would like to talk about a little bit the motivation of this topic. Then I will define some quality levels, then go further to the approach during factory visits and audits, the methods for incoming inspection, and finally, I'm going to conclude with the concepts for quality control. Well, the motivation. Why is supplier development necessary? That's the question that is, I think, the very beginning of all these activities related to bearing supplier development. And the most important motivation for this topic actually is cost reduction. Cost reduction, cost reduction. This is highly important to everyone, but this is not everything. Apart from that, we would like to, for example, reduce our delivery times. As we all know, sometimes some bearing suppliers sold all their production for the next several months. Lead times can sometimes even exceed more than a year. And if we need a bearing, then we have to somehow develop bearing suppliers that can deliver on rather short notice. In this context, certainly we would like to increase our flexibility. Sometimes we need to increase our quality if we would not be happy with the products from our existing suppliers. And apart from that, we might also think about the introduction of special solutions if we would like to go away from mass production. In this context, I would like to refer to, for example, wheel hub bearings of passenger cars that in the past were just absolutely normal standard catalog bearings, either tapered roller bearings or angular contact ball bearings. And in the meantime, today's generation, we have the flanges and also the ABS system, the sensors integrated in one and the same part. And why not finding similar solutions with integration of other functions in the bearings in other applications, which certainly would need to have a supplier that can handle such requirements. Apart from that, our supply chain and our supplier base shall help for reduction of risks. We have several risks that need to be addressed. First of all, delivery problems of one supplier. We actually cannot control what our suppliers, each of them, are doing, or how they can prevent their risks concerning their production, and maybe for whatsoever reason they might have some problems. It can be a natural disaster like an earthquake, it can be a flood, it can be a strike, it can be whatsoever. Doesn't matter. We all know that sometimes there are situations in which a certain supplier is just simply not able to deliver, and then we have to find an alternative solution. Important is in this context, and certainly also with respect to this motivation on delivery time, we need to begin this process of supply development as long as we don't have pressure and as long as we don't have any problems. Proper supply development takes a significant amount of time. It is if you want to conduct all the audits, the bearing testing, etc. This is nothing that we can do within a couple of weeks, which means all these things need to be arranged before we have some issues, for example, delivery problems of one, just for being prepared. If we would start this process when it's too late, then what we see sometimes in the field is that people just skip this process and they just buy the bearings from somebody else, and then end up with eventually big quality issues. Quality problems of one supplier, next one. So if we if we face that the quality is insufficient, having alternative solutions would allow us to give our suppliers the necessary time for really solving the issues, and then they can come back. And if you only have one, we can send them 3 emails a day. Please provide us with your AD report or something like this, which doesn't help anyone, just keeps everyone busy. But if we would instead have, let's say, a broad supplier base with several options for any product we want to source, then we can handle such things easily. Currency exchange rates is one topic, and let's say very relevant these days, political influences. Political influences have or can have enormous impact on supply chains. Currently, we know what's going on in Ukraine, and let's say, what would happen if we would like to source from Russia. It's very difficult currently, and similar, let's say, embargoes, sanctions, or whatsoever can basically happen everywhere. There's no, and the relevant problem in this context is that all these things happen quite suddenly. A lot of people didn't expect that the current situation is possible, would have been possible, etc. And apart from that, we have, for example, currently in China, we have the very strict restrictions concerning COVID-19, which also has impact on supply chains. As you know, in China, they follow the zero COVID strategy, which currently becomes really challenging. And there, let's say, measures can be likely to significantly inhibit delivery on time, etc. And there are lots of more things that can happen. For example, a container vessel can suddenly be stuck in the Suez Channel. That's what we faced in the recent past, etc. And therefore, for all these methods, we need to have a very flexible supplier base. And if we would have only one supplier, or let's say all our suppliers would be from the same country or the same region in the world, then we would be directly exposed to all these risks, and that's why we need to address these risks and find alternative options. So next, why shall purchasing be involved in quality assurance? Well, just let me briefly summarize this. And I think the first one is, the first line here is most important. We all have to be aware that each supplier approval is a general quality risk. No matter how many audits we do, no matter how much bearing testing we do, we can never bring all our risks down to zero. There will always be a remaining risk, and that's something we have to take into consideration. So just quickly summarize, the real quality will appear during serial deliveries. The truth is on the playground, as they say in football. And sometimes there are non-documented expectations on the materials, etc., which suddenly turn out to be important. In the past, we might have transferred some knowledge to our suppliers, new communication channels need practice, etc. And a lot of details in the collaboration can become critical whenever approving a new supply. And these are things that purchasing certainly needs to be aware of. It's not only the price, it's not only the lead time. These details need to be taken into consideration. Now, some further pictures on what can be important. So if we don't do this supplier approval properly, for example, if this would lead to change of a cage geometry, where this was a case in a railway application, for example, then we might end up in serious trouble. This used to be a brass cage of a cylindrical roller bearing, and I think the further pictures on this slide demonstrate why it is important to take particularly care for such details. If we would approve a supplier that doesn't fulfill our requirements, we might end up with hardening cracks in rollers, for example. These are topics that need to be addressed. These would lead to immediate failure. Shoulder fracture, due to improper undercuts of roller bearings can be an issue. These are the things. I'll say these are examples of cases where supplier development has not been done correctly, yeah, and our customers ended up in serious trouble. Profiling is a very important quality characteristics. If we would not have the proper raceway crowning, then we will again end up with premature failure. Poor material will lead to premature failure, and so on and so on. So it is important. We have lots of reasons to approve new suppliers, and the recent pictures just emphasized how important it is to do all these things properly, to take the time before you have pressure, to be sure that you can always rely on your suppliers fulfilling your requirements. And this brings us directly to the next chapter, the definition of quality levels. Well, especially in bearing trading business, it is quite common that people offer their products in various quality classes. Yeah, they have particular fancy brand names behind this. Yeah, and sometimes this makes sense. Sometimes I think it's questionable. While questionable does not mean necessarily that it's wrong. It just means it's worth asking a question. And on the other hand, we all know that requirements can be very different. Yeah, we do not always need the best of the finest or the finest of the best. It's not always necessary. And knowing your requirements very well, understanding your requirements and very well can help for saving plenty of money actually. And I would like to just contribute a proposal on how quality levels could possibly be described. And my personal proposal is, firstly, define standard quality, and and from the standard quality we can distinguish a premium quality level and a low-cost quality level. Yeah, there's something else like so-called electromotor quality and special requirements. I would not like to focus on this one today because this would take too much time. This shall just show that, let's say in most typical applications where we can distinguish low-cost, standard, premium quality, we can cover a lots of situations, but there's always something that doesn't fit in this simple scheme. So what does actually standard quality mean? Yeah, to me, this is nothing that comes from literature. This is let's say my personal proposal, and my definition of standard quality is very simple. It means that we can calculate the load rating of the bearings just based on the geometry and following the formula, all the equations that are given in ISO 76 and ISO 281. ISO 76 is for the static load rating and ISO 281 for the dynamic load rating. And if we do this, and if we then do our dimensioning and lifetime prediction, according to these standards, then our resulting expectation on the performance of the bearing must be fulfilled by the real product. This is basically what standard quality means. So we take a bearing, we look at the geometry, we calculate the load rating. With the given loads, we can calculate lifetime, and the bearing needs to reach this life. That's basically what standard quality is about. Nothing more, nothing less. And what does this mean in technical terms? Well, what some assumptions that are behind these two standards, not each of them, let's say, written explicitly, is firstly that we have a hardness of 58 Rockwell C, material cleanliness according to ISO 683 part 17, we fine grinding of raceways instead of super finishing, and this is highly important, production methods according to the state of the art from approximately 1990. And this already shows us why we are, let's say, why we can distinguish premium quality. Firstly, what is the difference? There's no difference considering the static load rating, because in both cases we assume the 58 Rockwell C, but the real endurance exceeds theoretic life by far, especially in mixed friction. That's most important. And where does this come from? Well, firstly from higher material quality, and then from super finishing of raceways. So remember, the standard requires fine grinding, but nowadays super finishing is common practice, especially for small size bearings. And so that means in theoretically mixed friction conditions, we basically have full fluid lubrication conditions, and therefore our bearings perform significantly better. And the higher precision of manufactured geometry leads to a higher slope of the Weibull curve. So just very quickly, if these squares should be, let's say, or these are actually test results from our test rigs. This is the probability of failure, and this is the test duration, and the individual squares are test results. If we increase the repeatability of our manufacturing, and just by let's say applying tighter tolerances, this means the best ones would still be the same, but the worst admissible combinations of all our dimensions would lead to let's say the better, or let's say better performing worst possible samples, and therefore we can significantly increase the slope, and the L10 is where the Weibull curve just touches this line, would change dramatically actually. Low cost quality, again, we would have the same static load rating, but we typically do not really achieve the theoretical life, which means low cost quality can be totally fine, for example, for the wheels of a shopping cart, etc. Nobody cares for the life calculation. Just the static load rating shall be given, that it will not, let's say, break away or something. So now let's talk quickly about the factory visits and audits. The factory visits and audit are actually important for having some idea on how bearings are actually produced, how they can control their quality, what corporate culture they have, etc. Are they reliable, etc. And what shall we do? Firstly, we have to prepare ourselves. Then the inspection of the material flow, inspection of laboratory and inspection rooms, checking of drawings, etc. And then finally, discussion of requirements for documentation. So preparation of the audit is most important. If we would not be well prepared, we can always be happy with each supplier, or we can be unhappy with each supplier, because there's always something we can find that could be better, and certainly our evaluation would not be correct, would not be appropriate if we wouldn't be well prepared, and we didn't reflect what actually are our requirements. And therefore, for example, it's very important to simply ask the question: do we really need a premium quality, or could we possibly be fine with the standard quality, or maybe even low cost quality is enough? And here, just one sentence: no matter how low the requirements are, they still need to be safely fulfilled. So then, which types are most important to me? So is there something we can address directly? Which quantity do I need? Did I have problems in the past? If so, what kind of problems? So this would also help us for directly addressing these matters. Whom do I talk to, and in which language? Language barriers actually can lead to underestimation of the supplier. Because very simply, the people will not give the proper answers. And if we don't get the proper answers, we have to consider two options: either they don't know, or they are not really competent, or they just don't feel safe, don't feel secure with their limited language skills, and or they didn't understand the question or whatsoever. Yeah, and time planning is important. So always consider local culture concerning working and break times, etc. Yeah, and sometimes it can help to plan your departure for the next day, just to work around if people would just waste time by intention just in order to not show their details to you. Then mental preparation is highly important. So the attitude is, before we begin, every worker does everything wrong by intention and tries to hide it. Yeah? And the goal is we shall prove that this assumption is not true for any relevant detail. So it basically means we shall assume the worst in the beginning and get convinced by the best. This is nothing personal. This is just, let's say, the role of the quality audit. So then let's talk about the inspection methods. So which methods do we have? So the trivial methods for incoming inspection: counting the packages, looking at the packaging, visual appearance, outer dimensions, clearance, etc. Then we can measure the microgeometry, we can check the material, and apart from that, we have several testing options. Oh, this slide is a little bit mispositioned. So just quickly, if we do the visual inspection, what we don't want to see, for example, is transportation damages. We don't want to see chips and burrs here in the undercut of a tapered roller bearing. We can, and then this really makes sense, check every now and then the geometry of our samples, for example, the profile of raceways, circularity, roughness. And the good news is that this can be done non-destructively, at least partially, in many cases. So we do not need to damage a bearing for this, just for verifying that our geometry is okay. Metallography, checking the material quality. We don't want to find cracks. We don't want to have find such altered structure. We don't want to find such extra large inclusions or such very conspicuous carbide segregation or something like this. Unfortunately, such is normally a destructive method, and therefore we would need to sacrifice at least one sample. Then noise testing, also a common method, but a little bit more expensive. It requires a noise test rig. And the good news is the test takes only a few seconds. Without or with low load, and therefore allows a very high sampling size, up to 100% is possible. But if you don't take 100%, it is highly important to take the samples from different boxes, just for being sure that these samples are really independent from each other. So apart from that, frictional torque can be relevant. So here we actually need the bearing test rig. The test requires about a couple of hours, and this would be very helpful for example, for detection of internal design changes or fault degrees quantity or something, and therefore is a very powerful method. And the most powerful method actually is the endurance testing. And again, we would need a bearing test rig for this, and the test can take a couple of days for incoming inspection. And for example, if we would have, let's say, deep groove ball bearings, 4 pieces on such shaft, not in this sketch, but it could be an option. At high load, high speed, and then we can do this test until 2 times theoretic life. For example, at such condition, bearing life, theoretic life could be something like 50 hours. So that means in 100 hours, less than 5 days, we could achieve this criterion. And if we would do this, then we get a very high probability of detection of most critical faults. And therefore, this method can replace all other inspections. And for small bearing, this is a really affordable and therefore powerful method. So, and now, how can we bring all these things together? All these methods. Well, for the low cost quality, it's quite easy. certainly we shall visit the supplier prior to approval, and then do short audits at least every 2 years. Yeah, first sample inspection can be just a visual inspection, haptic testing of smooth function, outer dimensions, hardness of rings, chemical analysis maybe once. Yeah, and the same as incoming inspection. For standard quality, we should do a yearly audit by experienced auditor, especially because things can change quite quickly. And for the first sample inspection, it would be recommended to furthermore check the microgeometry and also conduct the metallography to really be sure that the material would be qualified. And every now and then, following this for the incoming inspection. And the general concept is that for standard quality, the quality shall be ensured through documentation by the manufacturer and the audits. So basically, when we go to the audit to the plant, then we shall let's say check whether they would have proper records for every item, for everything that they did for us. Yeah? And for premium, it is the same, but for premium, basically with some additional thing, because for premium quality, we expect that theoretic life would be outperformed, and therefore we must conduct live testing, and certainly we shall do the quick live testing for incoming inspection. Otherwise, we would not be capable to really control that we can really rely on this outperformance of theoretic life. So the quality is ensured through documentation by the manufacturer and audits, but additionally, our endurance test runs will show possible trends. And now comes the interesting question. If we, for example, currently have traveling restrictions, for example, with China, it is not possible or very difficult, at least, to visit China nowadays. If not being there from the very beginning, then the audits are not possible. And now we have two options. Either first we could say, okay, we just forget about the audits, we just believe, or try to do the audit virtually, which doesn't really make sense. Or we can implement these quick live test runs as an additional method, just for catching more evidence, for catching more information on how well these bearings actually do perform. So and with this, let's say, proposal or inspiring thought, I would like to conclude and summarize the presentation as follows. Firstly, our quality control concepts have to be aligned with the quality level, and furthermore, both initial approval as well as constant verification are essential. Regular supplier quality control requires both audits and sample inspection. Premium quality means outperforming theoretic life and therefore requires regular live testing, and quick test runs are a powerful method for incoming inspection, especially for small size bearings. And certainly if the audits would not be possible like nowadays, then this can be a powerful tool. Thank you very much for your attention. And now I think, I would be available for your questions, or just send me a message, or send me an email, and I would be happy to take care for this. Thank you very much. I'm looking forward to hearing from you.